Hello everyone, this is a presentation of my course project of the network science and applications. So in this project, I analyze the urban areas transportation networks. And we set up a system model to run network algorithms in order to give solutions about the urban areas traffic congestion problems. And the two main problems we focus on is the shortest path between two cities and the whole layout of the lowest cost of the transportation networks. And in our system, we apply minimum spanning tree algorithms and digester algorithm to analyze. So first, if we get a real map like this, we can set a node at each cross. So we transform the map into this one, and then we can finally consist these nodes into a node network. And finally, we transform the graph into a matrix in MATLAB to analyze. And here is an example, and it's the adjacent matrix of this known graph. And to set a system model, we treat every city as a node, and then we link them to be an undirected map. Each edge between two nodes has a weight, whose value is the driving distance between these two cities. And this is how we set the map model. As we mentioned previously, we treat the cross into a node. So we consist this node into a node network graph and then transform the graph into matrix. The algorithm we use to analyze our transportation network, and the first is the digester algorithm. And we use digester algorithm to analyze the shortest path between two cities. Like if we choose city number 1, we want to analyze all the other cities like city number 2 to city number 13. We want to find the shortest path between city number 1 to city number 2, city number 1 to city number 3, and so on. Finally, we want to find the city number 1, the distance between city number 1 to city number 13. So for a given graph, digester algorithm can find the shortest path. It chooses the unvisited node and every other node. It chooses the unvisited node with the lowest distance and gets the distance between it and every other unvisited neighbor nodes, and renew the neighbor node's distance if it is smaller. And first, we set the distance to source node to be 0, and second we set all other distance to be infinity. Use S to be the set of the visited node, and S is initially empty, and use Q to be the Q2 and contains all nodes at the beginning. While Q is not empty, we select the element of Q with the minimum distance and add U to the list of the visiting nodes. During this procedure, if we find the new shortest path, we just set the shortest path with the new value. And after the whole process, we can get the selected cities and to the every other cities and the distance between them. The second algorithms we use to analyze is the minimum spanning tree algorithm. And first, I want to introduce the minimum spanning tree. It is just a tree that consists of edges of nodes in a weighted graph that connect all nodes without any cycles. And the total weight cost is the minimum. In order to make a trade-off between the shortest path between one node and the other, and the lowest cost of the whole transportation network, we use prime algorithm to build the minimum spanning tree in our system model. The prime algorithm is a greedy algorithm, so we can use it to find the minimum spanning tree in the weighted, the undirected graph. We finally get the tree with edges connect all nodes, and the weight is the minimum. For the simulation, we first get a data table like this. We first get a data table. You see there are 3 columns. The first 2 columns is the city numbers, and the last column is the length, which is the driving distance. Like you see, the distance between city number 1 and city number 2 is 4. The distance between city number 1 and city number 3 is 5, and so on to the city number 33 and city number 34. The distance between these 2 cities is 5. So we transform this data table into a matrix. You see, like this. This is the initial matrix which records all the distance between 2 cities. Like this distance between city number 1 and city number 2 is 4. The distance between city number 1 and city number 3 is 5. Let's see if we are right. You see 4 and 5. We are right. And then we transform the matrix into adjacent matrix, like this. If city number 1 is not directly connected to city number 10, then the distance is infinity. And the distance between city number 1 and city number 1 is 0. And then we use algorithms, which is digester algorithms and minimum spanning tree algorithm to analyze the whole system. Here is the result of our minimum spanning tree algorithm, which is the Prim's algorithm. You see, if we want to, we first enter city number 1, then we get a whole layout of a routing plan with the minimum cost here. Okay, let's do the simulation of our minimum spanning tree algorithm. You see, here is our routing plan. If we want to set the minimum layout routing plans, we have to set the route number 1, which is the route between city number 1 and city number 13, and the length is 1. And we have to set a route number 2, which is between city number 1 and city number 8, and the length is 2. The following route, we finally get a route number 33, which we should connect city number 30 and city number 24, and the length is 3. And if we draw this 33, then 33 routes in our graph, we can get the final plan of our urban areas. And then is the simulation result of our digestion algorithms. So let's perform our digestion algorithm for the urban areas. So if we choose city number 1 to analyze, and we want to get the shortest path between city number 1 and all the other cities in this urban area, we just enter 1. Then we can get all the plans, like the shortest path between city number 1 and city number 2 is to go through city number 18, and the path length is 3. And if we want to go from city number 1 to city number 30, then we have to first go to city number 20, and then go to city number 34. Then finally you will arrive at city number 30. The path is 5. And if we want to find the routing plan for city number 4, we can enter 4. And we get all the plans. Like if we want to go from city number 4 to city number 32, we should go through city number 1, and the total length is 5. So in this project, we built a system model successfully to analyze the problem in our urban cities, which we mentioned previously. We want to solve the problem of the shortest path in urban areas and the whole layout of the minimum cost of the routing plan. These two problems, we use digestion algorithms and the minimum spanning tree algorithm to analyze and get our successful result. And the extended work should be use different models to take traffic rules and traffic flows into consideration. Like I mentioned in my paper, some students use the traffic flows into consideration and the gas into consideration. And we want to improve our classical algorithm to get a faster speed for large networks. And that's all my project. Thank you.